In this video, we're going to take a look at the basics of Android hacking. We're not going to do any hacking in this video. It's going to be a general overview, but it'll form a good foundation for the future videos where we do some practical demonstrations. We'll start off with the OWASP top 10 vulnerabilities for mobile, and then we'll have a look at the general approaches for hacking Android applications or for reverse engineering them, and the languages that are used. So what languages do you want to be familiar with if you're going to be doing some Android pen testing? The structure of APK files, so what files are inside them, and what do they contain, and some of the common tools used for Android hacking. Obviously there's a lot, so we won't be going through all of them, but we'll go through the main ones and we'll also have a look at what some of those tools look like when they're running, have a look through some of the documentation and stuff like that. Finally, we'll have a look at some resources. So there's a lot of practical labs, there's a lot of different tools which we're not going to cover in this video, a lot of great tutorials and resources online, so I'll just try to point you in the direction of some of those if you're interested in learning more. So let's start off with the OWASP top 10 for mobile. As you can see, the 2023 list is being worked on at the moment, and you can join the Slack channel, but there will be a first draft out soon. So it looks like the last draft or the last list that we have to work with is 2016, this top 10 mobile risks. And that just means, I guess, that nothing really has changed much since then, that they still believe these are the right priorities. These are in order of how severe they are, basically. So if you were looking to secure your mobile app, you'd be looking to do it in this order. And the first one is improper platform usage. We've got insecure data storage, insecure communication, insecure authentication, insufficient cryptography, insecure authorization, client code quality, code tampering, reverse engineering, and extraneous functionality. So you can click on each one of these and go in and have a look and see some information about it. For example, reverse engineering. I thought this one's quite interesting. So it says that an attacker will typically download the targeted app from an app store and analyze it within their local environment using a suite of different tools. It's easy to exploit because the attacker can just perform an analysis on the binary to find out what strings are in it, the source code, the libraries, algorithms, etc. So unlike whenever you're dealing with, well, I mean, this is going to depend as well whether you're talking about Android and iOS. This is just the general mobile list, and there's more information here. I'll not go through all of this, but if you're dealing with a binary, then it's going to be a lot harder to reverse engineer something if you can't get back to the original source code, which with Android apps we can. So we'll be able to get back pretty much the original Java code, and we'll have a look at how we can do that and how we can patch APKs and stuff as well. So that's it. I'm not going to go through all this. You can go through this in your own time. Let's go back and take a look at the next part. So what are the general approaches to hacking Android applications? Well, as is quite common with hacking any kind of application, we've got two main fields. We've got static analysis and dynamic analysis. We can analyze the source code of the APK, as you can see, source code review. We can also potentially patch the APK, so make some changes to the code and then redeploy it. And we can have a look at the permissions. So we can do all of this without actually running the Android app. Or we can look at dynamic analysis, so we can actually run the app in an emulator on a real device and analyze the behavior. We can intercept traffic, and you'll notice that I've got SSL pin in here. So this is something that we'll look at on a future video, but if you're used to using something like Burp Suite for web hacking, you'll know that whenever you want to proxy the data that's going to and from the website, you have to use Burp's SSL certificate, so that whenever you set up Burp, that's the first thing that you'll do, is basically trust it and say you want it to be a man in the middle because it's something that you control. However, when it comes to APKs, to Android applications, often the app will actually have built into it that it will only accept a certificate from a certain source, so from the official source, which means it's not good enough for us to just say, okay, we want to inject our own SSL certificate and that's what we want to use like we would in Burp. You can do it, but we basically have to go through this SSL pinning process. So we'll have a look at that in a future video, but just want to mention that if we wanted to be analyzing some of the traffic that's going to and from the app and manipulate it, then this is something we'll need to look at. And then also API testing. So again, if you're familiar with web hacking, similar sort of things that we have here. And you will find that some tools will do a bit of both. So you can do some static analysis and some dynamic analysis. And yeah, we'll look at some of those as we go through the tutorials. So there are some languages that you'll want to be familiar with if you're reverse engineering Android applications. Obviously Java is a big one. So most of these APKs are written in Java. And you'll see that I put here small e and dex as well. Essentially, whenever you compile the Java, whenever you actually create the APK, it's going to have this Dalvik bytecode, which is this DEX, which is kind of similar to if you compile like a C program. So you write some code in C, it's a high-level language, you compile it and you end up with a binary application. So you couldn't just read that binary, and it's similar here, but you have this middle stage, this small e, and that's kind of similar to if you had a C program. You compile it, you could actually disassemble it and get the assembly code, so it's not quite the ones and zeros that we can't understand, but it's not quite the high-level C language. It's easy for us to understand. It's kind of a middle ground where we could essentially modify some of those instructions, and this is quite similar. So you can convert DEX to Java, but you might not get back to the original code that you're able to just recompile, whereas if you just change the DEX to small e, even though you'll be working with a syntax which isn't as easy as Java, it'll be something that you could just modify instructions and then essentially recompile it back to its APK form and run it. You also have Kotlin, which is a language I'm not really familiar with, but it is interoperable with Java. It has null safety and I think quite a nice syntax. As far as I'm aware, I don't really know too much about it, so maybe we'll see some code that we'll be able to reverse during the demonstrations in future videos. And then you've got C++, you've got some C# and JavaScript. You might see other languages as well, but these are some of the main that you'll be dealing with. But of course, Java is really the main one. So APK stands for Android Package, and it's basically what you would install if you want to install an Android application. It is essentially a zip archive, so you can just extract it, you can unzip it, and you'll end up with these files and directories. And the Android manifest has the package name, version, permissions, components. We've got a meta directory, which has the metadata, as the name would indicate. We've got classes.dex, so that's what we mentioned previously, the Dalvik bytecode, which is compiled from the Java and Kotlin. We've got our libraries, so native libraries specific to the device architectures, the resources such as images, layouts, strings and styles, and also a binary file containing the compiled resources from this directory. So we'll be able to use tools to extract some of these. You will get like binary versions, so there are tools like apktool, which can be used to actually extract these, and then you can just open it up in like VS Code or Codium and go and have a look at the original source code. So here's some of the main tools that you'll probably want to be familiar with. I've broken them down into static and dynamic, although some of the tools do a little bit of both, but we'll have a look at them in more detail. The first one then is apktool. As I just mentioned, that can be used to decompile and recompile APKs. Let's go and take a quick look at it. So I'm on the GitHub page at the moment. You can install this, I believe, either with sudo apt-get install or maybe it's pip install. It might be installed by default as well if you're using something like Kali Linux, but as it says here, it's a tool for reverse engineering third-party closed binary Android applications. It can decode resources to nearly original form and rebuild them after making some modifications. It makes it possible to debug small e code step by step, and that's the assembly code essentially. And it also makes working with the app easier because of the project-like structure and automation of some repetitive tasks like building APK, etc. So yeah, let's go and take a quick look at it. I've got it installed, as I say. I think let me actually just do sudo apt-get install apktool. Yep, so alright, so it was installed here. What I will say is if we have a look at it, let's do apktool. See, it says here dirty. I've done some CTF challenges in the past where it's not quite worked for, I think recompiling has caused some issues, and I've actually had to go and download the version from GitHub and use this one. So yeah, worth bearing in mind, what's this, 2.7.0, and this is 2.5.0 dirty. So yeah, if you have any problems, maybe go and try the latest version. And the help menu gives us some information about how we can use it. You can also use TLDR as a tool I like, which doesn't have every tool, but if it does, it'll just give you some generic commands. If you can't be bothered reading the manual or the help menu, you can just like grab something here to copy and paste. And I've also got an application here. Let me copy this, what's it called? Android Insecure Bank. So I'll show you some of these at the end, but there's a lot of different intentionally vulnerable apps that you can use to learn. I've not really played around with many of them, so I'm not too sure if this is the best one, if there's better ones. I know OWASP have Security Shepherd, and there's a lot of good ones on Hack the Box as well, like Retired Mobile Challenges. So yeah, you've got plenty of options, but just for demonstration, let's do our apktool. You can see here, this is saying decode it with D, so I'll do D, and then insecure APK, and yeah, you can see it's going to start extracting this stuff. And let's see what we got here. Let's go into Insecure Bank. There we go. All right, I'm going to open this up with code. And if we have a look here, we've got this YAML file, we've got our Android manifest. So this, as we mentioned previously, has some information about the permissions, the Android app, the version, the name, things like that. We have our intents here as well. We'll talk about some of this as we get into future videos. I don't want to make this too much of an actual practical demonstration, just want to kind of show some of the tools we've got and just a bit of basics about how they work. So here's our Smalley as well. Let's go in and have a look. We've got, so you can see here, like change password, for example, or change password.smalley. We can go and have a look. And this is kind of similar to what you would see with like assembly code. Not quite really, but that's the best comparison really we have to it. So you could basically go and change conditions in here. So if you just want to change like an if-else statement, you could go and change that quite easily. What else have we got? We've got our resources here as well. So this is all our images and things like that. And we've got our original. So this is not gonna, I can try and open it, but it's basically, this is the binary. So notice that that's Android manifest.xml, but we can't actually read it. So if you wanted to be able to actually read that sort of stuff, that's why you need to use a tool like apktool rather than just unzipping the APK. In fact, let me go back. I'm gonna remove this. Remove. And yeah, we could make some changes to that, by the way, and then do our recompile. You can see here we can build it with the B flag, and then we could just go and try the app out after making some changes. So I'll remove this, and let me just show that if we do unzip insecure bank, there we go. We can, all right, that put it all into the same directory, did it? Okay, well, I'll just open this up with code as well. All right, meta.inf, we've got our, no, that's my Git repo. Okay, no. All right, so we've got this classes.dex. So again, if I open this up with the text editor, it's not going to be readable. And this is the sort of thing that we need to compile. We can actually go and get that back to the original Java source as well. So we'll show how to do that soon. We've got our resources, but essentially this isn't giving us anything readable. So we can't just unzip it and expect it to work by default. And the next tool is dex-to-jar. So this will convert dex files into Java class files. So what we just did there in terms of unzipping the APK, we could do that, and then we could use dex-to-jar to convert that to Java class. In fact, let's go and take a look at that. So over on the GitHub, first of all, and this will give us some information about how we can use it and how to install it. I believe this was just another sudo apt-get install for me, but you could download it manually as well. And let's go and try it out. So we've got, it's D2J. If you do D2J, then hit tab, you'll get this autocomplete up with all these different conversions. And we might want to convert it to a jar file or to Smalley, like that assembly code that we were just looking at. We could convert it to, well, let's do it to jar in this case. Dex-to-jar will do. All right, so D2J-dex-to-jar, and then we can provide it classes.dex. That's going to create a jar file. And then it basically just, depending on the tools, some tools you'll be able to just open up the classes.dex and it'll do this for you as well. Other tools, you'll need it to be in the form of a jar, or you'll need it to be like a .class file. But where have we got that now? Let me see. Yeah, so we have this jar now as well. And let's go and take a look at another tool, because we want to have something to open this jar with. We also won't be able to open that with code or Codium, so let's go and take a look at another one. And the next one is jadx and jadx-gui. So this will decompile and analyze APK and Java class files. And there are other ones as well. There's like JD and I think JD-gui. I normally use jadx, and I think this can take some different formats. So let's see if it can open the jar file. And what else we have? aapt to compile and package APK resources. So let's go and take a quick look at these two as well. So let me try and open up jadx-gui and see what sort of files it'll take off us. So please open file. Let's see, open file. We'll go to desktop, and let's try and open up the dex first of all. This is supposed to be the Dalvik bytecode. All right, so we've got our Android support. Looks okay, doesn't it? We've got our functions here. See here, insecure bank. Can I zoom in? No. Maybe there's another option to zoom in, but I can't find it. So here we go. We can go and basically have a look at some of this code. This is like the actual Java code essentially. You can see here we've got our functions in here, and that's wrong login, view statement. We might have a look through here and see, do we have any passwords? Maybe there's some hard-coded passwords in here that we can just use to log in. And this is obviously our static analysis. So if you want to just try and find out what the program's doing without actually running it, this is the best way to go. Let me see if I can just close that as well. Well, let me try and open. Do we want to save it? No. I want to open the jar file, see does that work for us. So we open up the jar, that looks good as well. Go into our insecure bank, there we go. So we can see what the port's being used here as well. It means you see here super secure passwords. We've just found out one of the passwords. Obviously, this is intentionally vulnerable, so there are many vulnerabilities in this application. Let's also just try, we've tried those two. Let's try and, what did we do? We did dex, we did jar. Let's try and do apk. Try to open up the apk, and that's fine as well. All right, so jadx-gui is basically allowing us to open any one of those file formats to view the source code. Awesome. All right, I'm going to minimize that. I'm going to go back over. The other thing was aapt. So again, we can just check the help. There's quite a lot of help options in here. So you know what I like to do, TLDR, I'm not reading all that. And here's a few options. So we can list the files contained, we can display the metadata, we can create a new APK archive with files from a specified directory. So essentially, we can list the files, we can create a new APK package, some of the same stuff that we can do with apktool. Let's try and do aapt list and then pass in that insecure APK. There you go. So it's listed all the files that are in that. So a lot of these tools will perform a lot of the same functions as well, but there will be slight variations, and maybe one of them will work in cases where others won't. So it's good to be aware of them. So the next tool is Android Studio, and I've put this in static because it is primarily an IDE used to write, test, and debug Android apps, but as it mentions there, debug is dynamic, so we can also run Android applications in emulators, and it has some plugins and like additional features in there. So this is a very powerful tool, and I don't have Genymotion installed, but this is something quite similar. So these can do a lot of the same things. The Genymotion is more focused on the dynamic side, and it does have some features in terms of the dynamic analysis and emulation that Android Studio doesn't have, and vice versa. So in some cases, maybe we'll need to use one over the other, but in a lot of cases, both will do a similar function. So we're not going to look at Genymotion. Let's go and take a look at Android Studio. So I'm just on the official website at the moment, and it has some information about it, tells you what we can do with it, and you've got some support in here as well. So how do we install it? How do we use the interface? What are the requirements? Get to know the UI, overview, accessibility features, keyboard shortcuts, stuff like that. So I'm not going to go through all the installation setup. Some of it can be a little bit complicated, but there's plenty of documentation out there, plenty of guides if you get stuck for troubleshooting, stuff like that. But you have to set up some like, your SDK, you have to set up some like virtual devices, so you can basically run like any mobile version on there. Let's just go and take a look at it because it'll make a little bit more sense. I'm going to open up Android Studio. I've just got an alias set up, so if you type that in, it doesn't open it, that's why. So I've just got like a bash alias, which is set to link that to another command. We open it up, we can create projects, we can open projects, we can access our virtual device manager. I'm going to profile or debug APK, and I'm going to select the Android APK. I already created this project earlier just to play around with it, so I'm just going to overwrite that project. You can see it's disassembling classes.dex, and here it is. So it's kind of like you would see in VS Code or Codium or something. We've got our project structure here. We've got more about our files here. You see up here, we can click play. We can hit debug as well. We can open up our device manager. So I've just got one installed here at the moment, Pixel 6 API 28. You need 28 or below if you want to use it with the mobile security framework, which we're going to look at shortly as well, which is why I've installed that one. And I did that on a Pixel 6. So again, you can pick your device. You can have multiple devices because maybe you want to test it on various systems, tablets, phones, different versions, different APIs, etc. But yeah, we've got that set up. We've also got some other things down here. So one of the tools which I'm going to mention shortly is Logcat. So you have that in here. You've got app inspection, profiler. Let's just run the APK. So hit play at the top, and you can see that's opened there. Let's try and, can I open that in another window? There we go. All right, so this is it open, and we might go and try and put in some credentials. It's quite slow to type, actually. We did see that super secure password, but I can't remember, was that for something else? I don't know, was it for the actual login? Try and log in, all right, and then it's got the server and a port, so this is the point where we might want to go and start intercepting traffic and things like that. So if we were to go and modify the APK, maybe we patched it and we want to try and see if our changes are working, we could basically go and do that and then profile and debug it in here. Now let me go back. Let's see, do we have anything of interest in Logcat? No? Okay. All right, let's go back and take a look at some of the other tools. So more on the dynamic side. I'm not going to demonstrate some of these, so I am going to demonstrate the mobile security framework. This is an apt test security, so it's mostly static, but it does have some runtime and traffic analysis. And we've got drozer, so we can assess the security of Android devices and apps. Actually, we're going to have a look at the GitHub for that as well. We've got logcat, which is what we just looked at as one of the plugins for Android Studio, so it will view the logs that are generated by Android device or emulator. And then we have frida. This is a big one. It'll analyze and manipulate the behavior of apps during runtime, and this is what we'll be using for SSL cert pinning. And we'll look at that in future videos. It's quite complicated, and we don't have anything to kind of demonstrate at the moment. I want to try and keep this quite simple, but this is a very important tool, and we'll look at it further. So let's go and take a look for now. Let's have a look at the drozer documentation, and let's have a look at MobSF. So the reason I didn't demonstrate this one, I just want to show that it shows on their GitHub that we would like to formally announce that F-Secure has stopped further development of the drozer tool. With the amount of testing tools and techniques that have been developed since its inception, it would be near impossible to incorporate everything into one tool. However, we still think it's a good tool for simulating a rogue application. Penetration does not have to develop an app with a custom code to interface with a specific content provider. Instead, drozer can be used with little to no programming experience required to show the impact of letting certain components be exported on a device. So, in terms of what it is, it's a leading security framework for Android. It allows you to search for security vulnerabilities in apps and devices by assuming the role of an app and interacting with the Dalvik VM. So remember, we're talking about the Dalvik bytecode. This is what's going to run that. Other apps, IPC endpoints, and the underlying operating system. It provides you tools to help you use, share, and understand public Android exploits. Alright, so I'm not going to demonstrate this one, but I just want to make you aware of it and that you can download it. Although they're not maintaining it anymore, they do still recommend, or they do still suggest that it could be useful. But what we are going to look at is the mobile security framework. So I've got an alias set up for this, so let me just do type-a MobSF. So I've got this one up here, which is basically just going to run the run.sh on the local host, port 8000. If you want to do dynamic analysis, you don't have to, but if you want to do dynamic analysis, you'll also want to do type-a, where is it, emulator. So we also have this where you can just run this command. I just have that set in there to shorten things, but you can basically just copy and paste this, and then you need to provide the Android device name. If you don't provide it, let me try and run this. If you don't provide it, you're going to get this error saying there's no device. So what do? We do like list devices or something. I thought it was going to tell me there. -avd. Is it going to tell me how to list? Oh, there we go. List AVDs. Okay. So you can do -list avds. There you go. So that's the Pixel 6 API 28 that I showed previously, which means then if we try to run that, let me do, well, let's first of all, we'll run that one first. We'll do our emulator, and then we'll pass in this Pixel 6 API 28. I think I might actually need to close down the Android Studio. That's using the emulator from Android Studio. So I'm going to close that down. Oh, I didn't close it down. I closed that one down. Okay, there we go. And that's it running. So you see it's actually popped up with the app. Cold boot requested by user. Dismiss. Do I have to load that in there, or is it going to come up automatically? All right, well, let me open up another tab and we'll do MobSF. And this is just what we just saw, which is going to open this up on port 8000. So we can just go and upload an APK in here, or we can have it running in the background. Hopefully it's going to find it running in the background. If we go in here and do dynamic analyzer, you see that it's got this com insecure bank v2, so it did find that. Let's try and do dynamic analysis. Hit start, and let's see. Static analysis not complete. I don't know, do we need to do that first? I don't have much experience with this, by the way. Android Studio and APK tool and stuff I've used quite a bit, but I haven't really used this MobSF framework. Let's try, I wonder, can we do both at once? Try and do the static analysis as well. Let me open this up, APK, analyzing, okay. Let's see how the dynamics going. Is this analyzing? Don't know, it's not really very clear to me. You can use Genymotion as well, by the way, for this. The documentation is available here. I use this to set it up, so you can basically go and find out what you need to set for your paths and stuff like that. Remember, you have to be careful what Android devices and API versions you select because some of them won't be compatible. So you see here, Android up to API 28 is supported. If you're using Android Studio emulator, if you're using Genymotion or Genymotion Cloud, you've got different options. You've got a lot of information about installation and how to run it. So before leaving a comment on YouTube asking how to install this, just go and check out these docs and you should be able to find what you're looking for there. Let's go back. We've got a static analysis. Okay, so we can go back here. It's got a security score of 33 out of 100, which obviously isn't great. It's got our trackers detection because obviously it's an intentionally vulnerable app. Yeah, some information here. We've got our hashes. We've got some info about the app. We've got receivers, so we can basically go in and view and see what these are. What are the receivers? Enable wallet optimization receiver. We've got providers, track user content. We've got the files that are listed. We've got possible hard-coded secrets. Okay, I've got quite a lot of stuff here. Let me scroll back up. So we've got some analysis here, requirements. So this is actually going to try and tell you what vulnerabilities there are. So the application does not store any credentials in non-volatile memory. It tells you that it has initiated network communications. So just basically gives you some things that you might want to go and look into. Anti-VM code that it's looking for. Server locations, domain malware check, URLs, that sort of stuff. We can go in here, we've got permissions, so it's telling you what permissions are dangerous, what are normal. We've got some info about the API, or there's nothing in there at the moment. Stuff about the signer certificate. We can download the code now in Java, so let's try and download that and see. There we go, we can download that as a zip archive. Let me actually try that because I want to see. Let's see, we need to go back to the desktop and let's unzip 5e. We'll do code, com, Android, insecure bank. There we go, there's our Java files. So you can actually go and have a look at these now just in Java, which might be nice if you don't want to view it all in jadx-gui, if you want to be able to just go and view these in code or Codium or whatever your IDE of choice is, Eclipse or whatever, then you can do that here because we get some, I prefer the syntax highlighting of VS Code than JADX. Alright, so that's another cool thing we can do with that. I'm not going to go through all this. We can do a PDF report. We've got reconnaissance, malware analysis, a lot of stuff. And remember, this is just all the static stuff. So even if you don't have an emulator running, even if you're not doing any dynamic analysis, you can find out quite a lot about the APK through this mobile security framework. If you do enable dynamic analysis then, let's see, we've got frida logs here, errors, we can edit. So frida is a Python library, so you can do pip install frida to install it. And you see I've already got it installed, but you can actually go and edit some code here as well then. We've got remove root CA, logcat stream, so we mentioned logcat there as well previously. Start instrumentation, shell access down here. Available scripts, it looks like we have some just default scripts that we can load. Default, load that. Fingerprint bypass as well. So these are frida scripts that you can just load. Do we have one here for SSL bypass? SSL pinning. Alright, we've got hook, constructor. So yeah, we can load these. Again, I'm just trying to give a very, just show you what these tools look like, because whenever we're actually trying to demonstrate some of the exploits in these vulnerable applications, we'll actually have a bit more purpose in terms of what we're showing here. You can see here actually it does mention SSL bypass. It's looking for some things that aren't found. Okay, I'm probably missing some stuff here. Capture strings. Maybe we need to provide some more info. Maybe some things are missing. Yeah, alright, that's going to do, I think, for the demonstration of those tools. I don't want this to take too long and people be put off from even viewing it, so let's go back and have a look at some resources. So, some resources I've listed here is by no means exhaustive. We've got the OWASP Mobile Pen Testing Guide. We've got an Intro to Android Hacking by TechnoGeek. And TechnoGeek has been doing a podcast as well, the Critical Thinking Bug Bounty podcast. It was episodes 6 and 11, I believe, that they did some Android mobile stuff and talking about frida and things like that. So that's worth checking out. There is a mobile application penetration testing cheat sheet, an Android bug bounty reports repo, and Hacktricks is always good for finding some quick commands and tools and things to run. So let's just go and take a quick look at some of these. The first one is the OWASP Mobile Application Security Guide. So you can basically go and have a look here. They've got a Git repo by the looks of it. You can go and have a look here. I think this is mostly focused on how to actually secure mobile applications, but obviously if you know how to secure them, you also know how to break them as well. I haven't really had too much of a look through this. We've got the one from Techno Geeks, so this is a HackerOne post, and just a short introduction, again talking about some of the same stuff that we've discussed in this video. The structure of APKs, some of the common tools that are used, what the Smalley code looks like, and just enough stuff to get you started, some information about dynamic analysis, frida, cert pinning, things like that. So a good short article to get you started. I really like this one, Mobile App Pen Test Cheat Sheet. So this has a lot of stuff in it. We've got, let me actually just scroll down. So some testing distributions. We've got all-in-one security frameworks like the MobSF that we just looked at, but there's other ones. There's Needle, Objection, RMS. We've got some reverse engineering and static analysis tools. So apktool we looked at. There's also bytecode viewer. We looked at jadx. We've got APK Studio. We've got, yeah, there's a lot of stuff here. This is why I only put some of the key tools on because there are so many. And the same for dynamic and runtime analysis. We've got a lot of different tools here. There's drozer is mentioned, and you have some commands as to how to use it. We've got some network analysis stuff, so you're probably aware of TCP dump and Wireshark, Burp Suite. There is some other ones here as well. Bypassing root detection, SSL pinning. So again, a lot of different tools to do the same sort of thing. Security libraries, iOS application, we're not going to be doing any of that at the moment. And we also have here, I believe, some labs. So here you go, there's like 10 different labs or something here. What we just looked at there was the Insecure Bank V2. You've also got this What a Terrible Failure Banking Model. I'm not really sure which is the best out of these. I noticed this one is newer, but it doesn't have very many stars or forks. So sometimes newer can be better, but sometimes older and more popular ones can be better, especially if you are looking for some walkthroughs on different elements. But if you have a look at these will tell you some of the vulnerabilities that are in there. So you can see here there's a lot of vulnerabilities, and I think it's the same for WATF one as well. So these are the top 10 that you saw on the OWASP top 10. These are the vulnerabilities, and basically these are the vulnerabilities which are intentionally included in these apps to test. So I'll probably focus on this Insecure Bank V2 for now, but maybe we'll look at some Hack the Box challenges, some other CTF challenges, and if anybody has any recommendations, if you have a favorite vulnerable app for testing, do let me know as well. We've also got the hack tricks. So hack tricks, you can basically just go here and it's got a checklist of what to do if you're doing an Android pen test, and that'll be great if you're doing any kind of bug bounty stuff, because there is a lot of mobile applications for bug bounty. Again, I'm doing this obviously for Intigriti, so if you want to go and sign up to the Intigriti platform and check out some of the programs, these are the resources which will help you in that journey. And then finally is the Android report. So this will be very useful. You have some different bug reports on vulnerabilities that were found in different programs. Looks like mostly HackerOne. So you can have a look through these, get a good idea on what people have made money off before. Here's an accidental 70k Google Pixel Lock screen bypass, and hopefully you'll be able to find some cool stuff. Anyway, that's going to wrap it up for this video. It's been quite a long introduction to Android hacking. I wanted to keep it short, but I'm not very good at that. I will try to keep the future videos to like 10-20 minutes each, depending on the topic, and just keep them very focused. So we'll do practical demonstrations. We'll look at doing an episode on like SSL cert pinning. We can do one on patching APKs. And if you have any specific requests, if there's anything you would really like me to cover, or any vulnerable applications or challenges that you'd like to see reviewed, then you can let us know in the comments. And I hope you've enjoyed the video. Any other questions or comments, leave them down below. Thanks.